another GCSE Computer Science video with me, Mr Goff, for MrGoff.com. This video will focus on relational databases. A flat file database is one where all the data is held together in a single table. This might be done in a spreadsheet. In a relational database, there is more than one table, and the data in the tables is linked by using the primary key from one table as a foreign key in another table. Below, you can see on the top, we have a flat file database. Underneath this has been split into a relational database with a table for players and a table for teams. We've included the team ID field in the player table as a foreign key in order to create a link between the two tables. This means you would still be able to find out the team name for any player that's in the player database and their team colours because of the link that's been created. Relational databases can help us to overcome the problems of data redundancy and data inconsistency that are found in flat file databases. Data redundancy refers to storing data more than once. This obviously increases the size of a database. For the simple example we're looking at, it may not seem like that much, but for a large firm with thousands and thousands of records, it can make a very big difference to the size of the database they're trying to manage. Data redundancy can lead to the other problem, data inconsistency. This is because each time you have to type in that same piece of data, you have a chance of making a typo. This has led in our example of our flat file database to one of our players having Dolphins misspelled as their team name. If we were trying to correct the problems in a flat file database, we'd have to go through one line at a time to fix them up. If the team name were wrong in a relational database, we'd just fix it once in the team name field in the teams table. Inconsistent data could lead to inaccurate results from queries, where for instance, Jim Smith might not be identified as being in the Dolphins team. When designing a database, it helps to first display the relationships between each of the tables you intend to use. Relationships in the database can be categorized as one-to-one, one-to-many, or many-to-many. To work out what kind of relationship you're looking at between two entities, you should consider the relationship from both ends. For instance, a student and report card have a one-to-one relationship. This is because any one student will receive one report card, and any one report card will be for only one student. If we look at a form group and students, then we can say that any one form group will have many students, but any student will only belong to one form group. If we consider a more complex relationship like teachers and students, we would say that a teacher will have many students and a student will have many teachers. This is a many-to-many relationship. The process of converting a flat file database into a relational database is known as normalization. A key part of this process is to remove any of the many-to-many relationships that we've modelled. A common example of this is found when you see an order for a business. One order is likely to contain many products. At the same time, one product is likely to be on many orders. We shouldn't be implementing this many-to-many relationship, so instead we use this link table. An order is comprised of several order lines. So now we have an order will have many order lines, and an order line can only appear on one particular order. However, if we look on the other side, one product could appear on any order line, but there might be many order lines with a product on them. So we've created a link that allows us not to have to implement a many-to-many relationship. You'll learn more about this if you go through to A-level. That brings us to the end of this video on relational databases. Join me again soon when I'll be doing a video on structured query language. Use the resources at MrGoff.com to help you revise computer science. And until next time, it's bye for now.